that's relevant or related. It is the concept of data, and if you see something in the form of data, naturally you have to observe that what are the property that detail is offering to you, right? uh, and we are talking about the properties and the basic definition, basic essence of the data. Naturally it will be used. I mean, these concepts we will be utilizing when we will be designing a system for a search system or kind of situation, or retrieval kind of system or process. We will observe these details, right? We are not just discussing to revise these details. So today we will be focusing upon two parts. First, we will try to understand what is the retrieval process, right? So if you take data, I mean, if you have a data on your systems and if you have information on your system, so what is the mechanism you design to retrieve the data? What is the mechanism you design to retrieve the information, right? That's why it is important, and that's why we are discussing these properties. Because whenever you design a system, design an algorithm, your algorithm or your system or any tool basically is primarily going to deal with these properties, these features which we have discussed in the previous lecture. And we have said, we have underlined that in computer science at least, because in all situations your system will operate on a data, maybe information in some cases. So it is the feature which will play the most important role, right? Your algorithm will be operating on one of the feature to perform its task, right? So that's why most of the computer based or computer science based research or any design work is primarily prefixed with a feature engineering kind of situation. So maybe in the early phase, during pre-processing or during preparation, you must have some sort of logic which will identify the suitable parameter, suitable feature, or maybe it will be preparing your data in some sort of organized structure, so that your actual algorithm will operate on this data. And this is the usual setting in most of the domains, research domains I'm saying, right? So that's one part we will discuss. We will briefly compare the data retrieval and information retrieval. That's what I'm trying to say. And second part, we will discuss the most important factor which is related to your course or syllabus. It is called the the view of a search process, how a search process looks like. So if you conceptualize this search process, because now we are moving towards the syllabus part, which is, that's why we are touching upon the very first topic in today's class. It is retrieval of data and information. And when we talk about retrieval, we should also think about the overall view of a search process, right? So within this search process, the retrieval is placed, obviously, right? So search process or the search operation, or maybe search search system is primarily the largest entity. Retrieval is placed well within it, right? It's a micro or macro level of processing within the search, right? So when we say retrieval, it means it's a mechanical process which is happening, which is basically going to be conducted within a search system, right? So let's revise partially the previous day discussion. So we have talked about different features and different elements of a data detail. Then we have talked about the two types of it based on the contribution. Like hard is something which is contributed, which is generated by the systems or individual users, and soft data is something which is being responded or added on this hard data, right? Then we have said that soft data usually captured or modeled in the user interactions or responses of a system onto a data object. Then we have said, based on the modality, let me add here, based on the content actually. Yeah, it is going to the next page. Okay, so based on the content, we have said there are three broad modality of data. Based on that, we have said there is a need of database system, which is nothing. It is a syntax or a structure where we can keep the data of our needs. Then we have realized the importance of data model, right? Data model is there to imply certain property, right? Because each and every database will have some property. Like in case of relational database, we have said it is the property of uniqueness which will be preserved, and it is the role of data model which defines some conditions to impose these property by using, like in the case of relational database, it is the constraints. Similarly, in other data model also, if you take any database model, like it could be a hierarchical data model, it could be a network, it could be XML, any database, it will based on some data model, right? So data model precisely defines conditions which will be applied on the data objects in the future, right? And as far as computing concerned, data model also control or defines the capacity of a data for future based application. Like if you are interested to get some processing on the data, basic level processing, you can do. Mining also can be performed, analytics also can be performed, exploration also can be performed on the data which we have in the database, right? So with this conception, we have taken this one particular figure where we have summarized most of the things related to the details which we have discussed in the previous class. And we have said that in the very first quadrant, in the very first level, we have, you know, this pre-processing kind of task where we are modeling, we are capturing the different requirements, right? And these requirements will be captured in the form of SRS. If you recall the software engineering process, this data design is, you know, the parallel track within it. So if you start designing software system, there is a set of people, there is a set of teams who are working upon the design of database or data part, right? So there are two parallel tracks within that. So one is designated to design the data part, data aspect. So for them, from the SRS only, they will take out some of the requirement statements where these data related details are there, right? That is what the usual setting is. This is happening in many cases. It's not only in the waterfall case or maybe waterfall based models. It is happening in the agile also, because agile is considered as the latest, maybe so-called recent, so-called, you know, most of the software companies are, most of the software organizations are having this agile based approach. So in the agile based case also, you will have initially some set of requirements, maybe in the form of story, maybe in the form of you know, paragraph anyway. So if you are related to data design team, you are going to read these few statements. You will not have this entire SRS, right? And that's what's the thing, because I have my experience working with the industry for 4 years. So probably I was there as a database designer, right? So I mean, we used to have these few statements that now you have to create this instance, this subschema, this schema, something like that. So to create that part, we need to have some basic or mini level of details, right? So these real world requirements are there. Then out of these, we will be taken out to develop the data objects, right? So it could be designing the database table, it could be designing the database, you know, constraints on the table, some foreign keys, some constraints, some new tables, something like that. So after doing this, after identifying the database, you know, objects, the next task is to define the entire structure, how these things are related, how these things will be operating, how these entities will be controlling to each other, right? So basically, in the data quadrant, the primary task is to define the syntax. Then if you go to and if you are interested to, I'm saying interested because again I'm saying that data is the detail which is equivalent to the information detail. So in the last class only we have taken this example. If I want to refer you or maybe any student from your class, I can use roll number or I can use names, DOB, email ID, these many details, right? So basically data and information are both are equivalent level of detail. But in the information case, it is more precise, it is more abstract, it is more meaningful to the human individual. That's the difference we can achieve, right? So that's why most of the, I mean, not you, most of the students from the previous year, they used to ask this question. So if both are having same impression, same reference in the real world, why we are processing data to make it information? Why we are working upon algorithm which is basically going to generate some information, right? So because both data as well as information, both levels or details are considered as a hard data because they are directly generated. They are being directly contributed by the users, maybe by systems, maybe by sensors, maybe by any machine, and we are going to utilize them for future purpose, like in the case of knowledge, right? So basically, while processing the data, in some situations, it is important to add these semantics, add these meanings to the data object, right? So what typical example I can take at this point, you must have recall this concept called part of speech in English. So in a sentence particular, if you take one sentence, there are different portions of it, right? We refer them noun, verb, supporting verb, conjunction, many things, right? So if you take these individual objects, it will not convey any meaning, right? So we can say that these are the data objects, we can place all of them in a structure, but if it comes to the meaning part, if you talk about the meaning part, how this entire set of object will convey some meaning. So in that case, you need to impose this part of speech, POS kind of mechanism, and declares that this kind of arrangement will convey some meaning, right? You can identify by reading this entire statement and say this sentence conveys something related to past, something related to future, something related to current, right? So that's a simple or basic example. Similarly, if you take this research paper, like scientific research paper, you can see that by having different portions in a single document, that single PDF is one information object, right? So if you take a research paper, it will have different sections like title, then introduction, then keyword, then important introduction. Likewise, so keeping all these data objects in organized structure in a proper semantic base informations, that will make more convenient to be used by user, right? So the primary objective of processing data, at least to convert it to in the form of information, is to make it more usable to the real world purpose, right? So once we process something, once we process from the data quadrant and make it information object, it is for the generic use, it for the to be consumed or make it so usable by the real world user, right? That's one thing. Now whenever we process data, it will and we process data with the objective to achieve or to convert into a information level of detail, it is naturally to make it more abstract, make it more usable, right? And basically it is more specific to certain scenario, right? So whenever we process data to make it information, naturally we will add some sort of compatible or usable in a certain context, right? And that's why sometimes it is called, or sometimes it is referred as a data plus semantic and data plus semantics with contextual information. So contextual information is nothing but it says that it will have something related to the scenario, something related to the situation, something related to a certain application space where this information object will be consumed, right? So it is like in this weather forecasting department or offices, they are getting data from sensors, right? And these sensors, which is continuously pushing the data to the servers, to their algorithms, to their programs, they are making it some sort of data analytics kind of mechanism and generate some sort of predictions, right? So these predictions are based on the data which is received from the sensors. Now, if you publish these predictions in the form of received data, maybe some modified data, maybe added comments on it, it will not be readable enough, right? And if you populate these findings, these observations to the general public, it will not be comprehensible actually. So that's why we need to have some sort of generic statement that we will have this much of percentage today, this much of temperature in the second half, this much of precipitation. I mean, there are many things which you can predict or estimate, right? So whenever we have a data and we are interested to make it information, interested to convert it into the form of information which can be easily consumed by the population, you have to make it with some additional details, and you have to transform it, you have to abstract it, right? So there are n number of application situations where we are processing data and making it more usable by the user by adding these many details, right? So there are two mechanisms broadly. One is basically either you can transform it, either you can transform the data into some other form, or you can simply, make it a real representation kind of arrangement, right? So we will discuss it maybe I think 15th or 16th lecture, where we will talk about how to process it, how to make data into information by using some algorithm. There is this term in the computer science, it is called diffusion, right? So diffusion could be one of the prominent research domain also nowadays, and it is called information diffusion, or maybe it is called data diffusion, right? So we will talk about this part in future. Just for time being, you can take that it is nothing but it is something we are adding on the data part, right? And making it more comprehensible, more readable, more usable, something like that. So that's one part. Now there are some situations where you can utilize this information which you have and apply to respond to a situation. Like one of the example we have taken, like if you are going for examination, you will be utilizing all the information gained you have and respond to a certain you can say situation, certain question, right? So these models which we are nowadays talking about, machine learning based model and any AI or ML based model. So these models are the typical example of knowledge based representation, knowledge based details or knowledge level details, right? So you have gained all these information object. Now if you are interested, like in the case of human beings, it is the knowledge object which makes them more knowledgeable or more experienced, right? But in the case of machines, because there is this thought that okay, why AI is required? So AI is required to perform the same task in a basically limited time and infinite times of iterations, right? I mean, modern AIs are also designed to perform the different tasks which human also can do, but it is just that we are humans, we cannot be doing the same task n number of time on infinite times for the real life. So that's why we have designed AI, right? So AI is also having similar capacity which we can also have maybe, and naturally if we are saying that it is having similar level of capacity or capability, that machine or algorithm, to train that also we need information object, right? So it is equivalent to training a human being, training a machine or algorithm, right? So whatever learning we have, whatever knowledge we gained after processing information object, after applying information object, respond to certain question, respond to certain situation, similar kind of capacity or capability we can also provide or achieve on an algorithm, on a machine, on a tool, right? And that's what we are seeing as a training or machine learning or deep learning, right? So that's one part. So this learning which we gain, which we have in our algorithms, models, this learning is basically referred as a knowledge. And it is basically achieved through some sort of training, some sort of repeated experiments on a human as well as on a machine, right? So that's some sort of analogy, and this wisdom part is basically not have any details into it, because it is a difficult part, or difficult at least for me to represent something in this blog, right? Because that's what I can assume, that in the real life we do not have any algorithm or system which has wisdom, and that's what is the space where we will have few systems in the future, coming future. There are few organizations who are continuously working to develop at least few intelligence, few capabilities on their systems or on their algorithm, which will possess some wisdom, right? And naturally, in the future, we will have this kind of system, as well as we will have some individuals also in the society. I don't know. Maybe in our society, in our surroundings, there are few people who are having wisdom at maximum, at most level. So once we have, we can add these details into this quadrant, right? So to be very precise, I do not have a precise idea about what could be the presentation at this level, and what could be the details we can identify as a wisdom, right? So that's why it is kept blank. You might have some your interpretation about wisdom, but that you need to check. So keeping all these things, this provides broadly some sort of idea that in the real life or maybe in the internet, we have many details. Some of maybe kind of data, some of them might kind of information, some of way of finding knowledge. There must be some which are considered as a wisdom also, right? So these are the there are the 4 levels of details available in the internet, which can be labeled as data, information, or knowledge. So it is representation, which is the most important part, because whenever we are going to interact with these details, the representation is the most important aspect as a computing or as a computer science situation, a computer science research related work, right? So with this, let's proceed. So primarily, now we can say that information is nothing but it is a data along with the semantics or meaning, right? And that's why it is called process data, right? So information is often referred as the most precise definition of information is it is a processed data, right? Because whenever we are applying anything onto it, it will make it processed, right? So naturally, if you talk about the characteristics of information, it is it is carrying the data as well as the semantics. It will provide some sort of abstract or precise or focused or specific to situation kind of representation. It is related to the organization of data object, right? How you are placing these data objects in a settings. Now, I mean, in the research domain, if you see in the most recent times, there are many fields which talks about how to interact with the data object, information object, not data object, because there are many systems in the world available where you are operating on the data object, not on the information object, right? So in the recent times, there are few research domains which have picked up, and it says like IR plus HCI. HCI you might have recalled, it is human-computer interaction. And there are many research fields which talks about the importance of users' interactions on the information object. I'm saying information object. So there are fields like interactive information retrieval, then it is called human information interaction, human information behavior. So if you search for these topics, they will directly tells you the different literatures available which talks about the importance and in the domains where users are interacting with the information object, not with the data object, right? So this is just for your information I'm sharing. This is nothing to do with the technical part. It is just for the awareness. Now let's proceed to a new discussion. We can skip this part because this is something again repeating. It captures some sort of representation which says that in the bottom, in the beginning, we have these many details as a form of data. Then we process it and make it abstract. We can achieve some lesser level of detail and refer them information, and then knowledge, then wisdom on the top. And naturally, when we have wisdom level detail, it will have a very crisp or very precise or very teeny level of detail, right? Because it has been derived by processing the huge details in the previous layers, right? If you see the left side part of diagram, which is two coordinate or two axis diagram, context and understanding, you can see the data and information talks about the past experiences, and that's what it is. So because data we have captured in the past, now we are utilizing this data and information in some cases to get the possible future application. So whatever experience, learnings you gained from this past data or information, we will utilize it to make ourselves ready, make ourselves more concentrated, related to the future conditions, future situations, future input, something like that. So knowledge is wisdom basically. So that's what I'm saying. In the machine learning based mechanisms, we train a model to predict or to operate on the future conditions, right? That's what. So basically, you can deal with the novel situations in the future once you have knowledge and wisdom in your system, or even in your case also. Right? Now, there are a few questions placed. This situation, which I have already conveyed to you, so we can escape. Now, let's go to the planned discussion part, which we have planned for today's. Right? I hope till this time things are corrected. Now, we are going to see some of the internal resource. So now, because we have thoroughly discussed that what kind of details we had in the data case and what is the kind of details we have in the case of information. Now, the entire focus of this syllabus, this course, is to perform some sort of retrieval. Right? Now, so let's have a brief idea that how retrieval on the data and how retrieval on the information object will be happening. Right? So, I mean, you can suggest some of the responses, and after that we will go into the internet, actually onto the internet source, to see how these two retrievals are different in nature, right? So I think we can directly go to this source. Let me take this query and share that screen. So stop sharing. I'm sharing this tab in a minute. Let me do it first. So if you are interested to respond to this question, you can also respond. Meantime, I'm sharing it on the screen. Meantime, I'm sharing that tab on the screen. So can you briefly tell me or briefly hint me that this is the basic difference between data retrieval and information retrieval? Just take 1 or 2 minutes to respond. Yeah, anyone?
Hello.
Yeah.
So in data retrieval, there we retrieve objects like data attributes or some sort of parameters. In information retrievals, we retrieve information based on that particular data set. For example, if I need to import some sort of names or addresses, that is data retrieval. But if I need to conclude to certain information that based on this particular address or based on this particular location, is this particular instance is spam or not? The spamming or not is information.
Okay,
Like
let me precisely say, Abhishek. Okay, let me say again. So, if you compare two concepts, I mean, if you are interested to compare two concepts which are equivalent, maybe similar. So, first of all, you need to say the parameter. Like on this parameter, I'm going to compare. So, if you compare data retrieval and information retrieval on the case of matching approach or maybe retrieval approach, so what would be in the case of data and what would be in the case of information?
so in case of data can be any, for example, if I have a data set of emails, credit card and some certain names and numbers with certain credit scores. For in case of data retrieval, we can retrieve their credit card score. We can retrieve their certain things which are there in the data set. But in case of information retrieval, we need to conclude based on their location and their instance. For example, a person cannot withdraw money from two different locations in one hour period. Like I cannot retrieve my money from Mumbai ATM and London ATM. So this will report as spam, and this particular cycle is known as information retrieval. Like
Right.
that.
So if you compare, if you are interested to perform some comparison between these, you can directly perform, like in the case of SQL-based programming labs, you must have gone through this data retrieval thing, where you are precisely mentioning a query and submitting it on the system. And in this Google search itself, it is providing some sort of information in most of the cases. Particularly if you go into the image search, where you are, interested to see the results, particularly in the category of images. Uh, Let me precise this here. Yeah, that's what I have searched. So now you can see we have simply imposed this query on the top. It says data retrieval. Let me make it more enhanced. Yeah, it's okay. And if you paste this query, search query here, you can have these many results. So these results are naturally appearing as information objects, just because they have been tagged with these informations, right? So I mean, initially we have this image, right? So initially we have these images in the system, and these images are being tagged with these tags, and that's why it is appearing in the Google search result as a response of this query, right? So our objective is to see what is the basic. I mean, there are many figures which are appearing to compare the data retrieval and with information retrieval, and you can see, I mean, there are many interpretation of it. Naturally, it is coming from different users or different documents. It has been placed by the different users in the global platforms, or maybe in the internet, or different repositories. So Google Search System has simply extracted all these things and publishes for us. So if you take anyone like, let me take precisely where parameters are given here. So you can read it, how these data retrieval and information retrieval is compared. So this parameter is important. So the very first thing is matching. So if you need to compare two approaches, data retrieval and information retrieval, and if you see their nature in the matching, how they perform matching. So in the case of data retrieval always based on exact match, like it is happening in the case of SQL. You can have you should have this entire parameter. You cannot have partial matching, right? So whatever you provided in the query, it will be exactly matched, right? In the case of information retrieval, it says that it will be based on partial match. I mean, we will discuss it. It is called, because information retrieval is based on one phenomena that is called balancing exploitation with exploration. It means, precisely for the time being, it simply means in the result, whatever result we will fetch in the case of information retrieval, it will have some results which are matching with the current query. Exact query will be matched on the results, but addition to that, there are some results which will be relevant, which will be partially matching also, right? And with this philosophy is particularly preferred in the case of information retrieval, or maybe information search system also, because we are assuming that each and every information object will be there with these additional details, which we are assuming as a semantics, right? So that was the basic philosophy. That's why we are saying that information is nothing but it is a data with some details, with some semantics, and we need to respond, we need to utilize this semantics. That's why we are having this partial kind of matching approach, right? Now if you take it like there is a parameter called model, which model you will be using. So it is, in the case of retrieval, it is deterministic, very precise, very exact, and in the case of information retrieval, it is probabilistic. How much that particular document is matching, how much particular document that information object is closer to the user query. So you will associate some probabilistic estimation of matching, probabilistic estimation of some closeness, similarity, right? So all these measures will be used when we have performed information retrieval, right? Now, if you see the parameter called data, so in the case of data retrieval, you can see there is a database table available, there is a structured database table available. In the case of retrieval, it is the free text. It could be a simple PDF document. So PDF document will have text. Primarily text, free text means you can take maybe a news article. So it will not have any structure. It will have entire details into one single layout, maybe blogs, right? But if you take scientific document like research, if you take research paper, so it is having text, but it is not free text. It is a structured text, right? Because we have different portions organized in different section, different way, right? Now, how to submit a query in the case of retrieval? So in the case of data retrieval, we provide simply either in the form of relational algebra, you can recall, or maybe you can have some sort of SQL, like, which is structured query language. So structured way you are having some syntax, like in the SQL we provide like select star from employee, right? And most of the queries written in the SQL are having these structured words. So when I say structured, it means each and every term will have some procedure attached to it, right? Like select is there. Select is a structured English word, right? So I hope you can you have this precision on this thing that why it is SQL is called a structured query language, right? So structured means query language part is clear to you, I hope. Query language means it is a language, it is a programming language which is designed to perform some querying or requesting on the data. But when it comes to structured part says, because if you see the previous name of SQL, it was SQEEL, SEQEEL. It is called SQL, right? It is called Structured English Query Language. But nowadays it is renamed, not nowadays, 10 years back, 15 years back, it was renamed as SQL, right? So this structured prefix says that whatever we write in the query language, it will be based on proper English words which represents structure, right? Like in any programming language, you can say sort. Sort is an English word which represents a procedure. Similarly, in the SQL, it is select, right? Which basically represents some procedure, some proper procedure, proper function attached to it in the backend, right? So that's why it is named as a structured query language. So now, in the case of data, in the case of query language parameter, so in the case of data retrieval, we are using maybe SQL, maybe relational algebra. In some cases, it is artificial. Like if you take this example of Google Earth. So I hope you have explored or utilized this Google Earth for some purpose in the past. So in the Google Earth, actually, it provides a mechanism to operate on the data, but on an artificial simulated view of the data. So that the Google Earth, that Earth image which we are facing in the case of Google Earth, it is a kind of simulated view of Earth by utilizing the coordinates of Earth, right? So they have created a simulated view by using this data coordinates, and there you are going to simply perform some sort of zoom in, zoom out, click based querying mechanism. So there are many. So this particular field is called in modern it is called novel query interfaces, right? So there you can have some alternate mechanism to operate on the data, right? This specific field is too vast to understand, which talks about novel query interfaces, right? Because just for the understanding purpose, if you see, most of the cases user is not familiar with the data. I mean, the data which is stored in the bottom. So it is the responsibility of individual or maybe data designer team that they should provide a simplistic, interface to the user so that he can interact or he can understand the data part. So out of this need only, this Google Earth has been created, right? So if a map is given to you, when simple 2D map is given to you, map of the world is given to you, it will become almost difficult to explore or to read, to understand the relatedness between two locations and its position with other cities, something like that. But if you create the same data by using some artificial or simulated view and present to the user, it will be more realistic. It will be more convenient to use, relate different things with one particular details on a specific region, right? And that's why there is a need of user-centric GUIs in the future. So in the future, we will have different GUIs where these kind of simulations will be available. And this is one of the upcoming area of research in computer science. Now, going ahead, if you read the information retrieval aspect on the query language, you can see there is a natural means that voice-enabled based query we are nowadays having. We are having query-based input also. You can not query, image-based actually. You can provide image and you can search images. And that is what natural input. Now, keyword is also there. Free text is also there. You can type or post a paragraph, right? So these things are there. Now, how you are going to interact with. What is the skill of query? So in the case of data retrieval, you need to provide entire query, but in the case of information retrieval, you can have a partial query also, or maybe incomplete. Right now, how different results has been matched or fetched. In the case of data retrieval, like in the case of SQL, we perform matching mechanism. Whatever, like you have said, select star from employee where employee equals to employee name equals to John, something like that, or maybe department number 10. So exact matching will be performed, right? But in the case of information retrieval, we cannot perform matching, right? You have to perform some sort of relevance kind of approach. How much relevant, how much similar, how much overlapping, something like that, right? So similarly, you can read it to any mini document to understand how these two phenomena are important, how different parameters can be utilized. So like you can read here, this is something else actually, it is extension for that. But as of now, you need to understand the basic difference between the data retrieval mechanism and the information retrieval mechanism, right? So this is primarily the second question for your classroom. In the previous class, we have taken some concepts, so there are a few questions from that part. Now, from this today's class, this is the first question. We are raising that what is the difference between data retrieval and information retrieval. So you should have a precise idea about these two aspects, and naturally by keeping these different parameters, right? So with this, now let's assume that we have some sort of idea about the retrieval part, the search part, right? I mean, naturally, before starting this course, also you must have some idea that how this information search or data search is being applied, being implemented, and because we are interacting with the search system on the regular basis. And beyond that also, whenever we are exploring some websites, on those websites there is a search field is given. So that's why I have said in the previous lecture that each and every application, each and every system, website tools are providing either search as a process or search as a system. So like Google system is the search system, but if you look into the institute website or any website, they are providing this search box. So they are providing in their website search as a process, right? So we have two views on the system. If you are into this classroom of this IR and web search, you should always have this idea. You should always have this point of view that in some instances the search is provided as a process, as a one process in the system, and in some situations it is provided as an entire one system, right? Yeah. So now two questions are important here, and not questions. Two focuses are important to be taken care of. First, why do we search at all? Why do we search at all? That's what you need to understand. You need to highlight for clarity purpose. Naturally, you will have some other understanding on it, some other point of views, particularly. So primarily, the first objective or the first aim or the first need of search process, conducting search, is to enhance knowledge, right? So if you are not aware about something, you will naturally look for these information objects, these data objects. So the search, or maybe in some cases it is called seek or seeking, right? So this seeking is something which captures something beyond search. Search plus something. So you can say search plus learning is called seeking, you can say. So search plus learning is called seeking, and it will have a different purpose, right? Searching could be like if you're looking for phone numbers, you're not there to learn the phone numbers. You're not there to remember the phone numbers. You're looking for a particular fact, right? But if you are interested to learn the reasons for the corona spread, so you are there to learn these factors. These you are interested to document all these things. If I am giving you assignment, like you need to identify the difference between search and information, so naturally you will be engaging with the search system to understand all these reasons, and some of them will be you will be documenting some of them, and these will be always with you for a longer time, right? So there is a difference, basic difference. and we have not modeled this part, and that's why we are not using this term, uh, seeking systems. We are using search systems or search engine, because search part is something which we can implement. We cannot implement the seeking part. But seeking part, this seeking and this learning part is always stays with the user interest or user engagement, right? Okay, so first and obvious reason for this search process is naturally to learn something, to enhance the knowledge. Now, the second is social awareness. In some cases, we are also interested to learn about something, and that's for that purpose we are gaining or we are acquiring these objects, information objects, data object, to make ourselves aware about some factors, some topics, right? Now, there are few situations where it is about developing a complex intellectual skill. So, if you are preparing for some examination and books are not available, so you will be going to a search system and interacting with to get all these possible information object, something like that, because you are not able to either purchase all these things or acquire those physical objects into your house or into your reading space. So whenever you are interested to learn these specific skill, you are going to interact or you are going to perform a search about these objects, right? So naturally, the last and the some sort of summarized need is you are always interested to stay on the top of the things, right? And that's the reason nowadays we are having social media platforms. If you observe your behavior on a daily basis, you are spending too much time on these platforms, and it is just because we are basically interested to stay updated about the things, right? And that's why we are observing these platforms, because these platforms are generating constant data across from contributed from the global user. They are publishing the data to you. So there are two services. So these platforms are pushing the data towards your end, right? But in few years back, most of the cases it was pull-based applications. So you go to certain website and pull the data. Like in the case of Google search, if you apply a query, the data will be responded to you. Results will be given to you. So it is a pull-based application. Based on your need, you are going to interact with the system and get the data. But if you go to the social media platforms, they are pushing data to your end, to your interface, to your login, and you are consuming it. So this makes basically some sort of affection with these platforms, and you are now addicted to these platforms with this feeling only, with this last fact that you are interested to constantly stay updated. That's the reason, right? So it is something related to a fact which is called survival of the fittest. So we are also now consuming this information with some sort of desperation to consume or to stay on the top of the things, right? Now, this is what we are looking for. This is a broad perspective. You can take or you can add more reasons here, right? So broadly, these are the four heads. Sorry. Now, so how do we search? That's the second thing. So first question we have said that, okay, why do we search at all? So that's one question. Second aspect is to understand is why do we search? How do we search actually? So, naturally we are interacting with the different systems, different interfaces to search the results. So in generic setting or in general situation, what we do, we are not having any idea. Sometimes we are not having any idea that what are the exact or precise input query, and how this query, my current query, will affect the results which will be generated. So we go to a search system without any clarity, without any certainty on the possible result, and type that query, right? That's what it is called, ad hoc mechanism, ad hoc settings, right? So initially when we are not having any clarity on the query term itself and relation between query terms with the possible results, right? So you can say both ends are uncertain. Your query term itself is not precise, not certain, and your results and their relation with query results is also not certain, not precise to you, right? So both ends are basically ill-phrased query and imprecise intent. Intent means this relation between query with result, right? So everything is uncertain, open-ended, imprecise, ill-phrased, something like that. So this entire interaction, this entire search scenario is called basically ad hoc searching, ad hoc mechanism. And for that we have defined, for this we have this platform called Google search system. It captures each and every possible ad hoc search scenarios, ad hoc search mechanisms, right? That's why it is designed with almost the best simplistic system we can have, right? So in this setting where both themes are unknown, unplanned or uncertain, often the searches are going to be engaged in many interactions, many iterations actually, right? Because we have not planned anything. And most of the traditional IR systems are supporting to query result paradigm, right? So if you apply a query, they will provide some results. Though precision is not there between your query, there is no connection between query and results. As far as user side concerned, system is there to respond you with the related results. That's okay. But whatever query we have imposed, we are not having any systematic way of evaluating the relatedness of this query and result. It is the system which is imposing these connections, right? So that's why modern systems are going beyond it. So modern systems are going to have this review element in between. They are concurrently utilizing your behavior on the search results. So you supply some query, system will generate some results, and the very next moment, when you operate on these results, that part is considered as a review, and your responses on the results will be considered, right? So when you apply the next query, probably it will consider this part also, review part also, to generate results too, right? And that's what the changes happened in the last 8 to 10 years, probably you can say, right? So these are the two situations. First is called simple query result paradigm, where the query generates the result simply. But in the second paradigm, it is said that all the intermediate interaction of user are being captured to generate the possible result, right? So you can correlate this paradigm shift with changes in the e-retail websites or e-retail apps like Flipkart and Amazon. There they are utilizing your interactions, inbuilt interactions, for n number of ways purposes, right? So this is what we are emphasizing. This is what the evolution happened in the last 2 years, last 8 or 10 years. So we will discuss the further details. Just lack of time, we have not started discussing this part. Actually, this is what I am interested to share with you, because this is something very important with respect to this particular course, and this models the entire search process, right? So tomorrow we will have this discussion on this part, right? So that's it for today's. If you have any question, so we have limited time. Any question from your side? Yeah, I hope you're not sleeping.
No, sir.
Great. So any question?
No, sir, no questions.
You can post your question on the Google Classroom also. It's open platform for you, right? Okay. I think, do you have any classes after this?
Yes, sir.
Yeah, please proceed for that class. We are stopping today's discussion here.
Thank you, sir.
Great.